All right, welcome back. So we're going to just continue with the derivatives. In the last video, we ended with the Laplace transform of the derivative. Oh, that should be of t. Was or is. I'm going to write it like so. It's going to be s times L of f of t minus f of 0. Okay, that's what we got from the last one. Let me zoom in just a little bit. There we go. Now, let's go ahead and take the second derivative. Okay. Of course, we assume that the Laplace transform exists. So now, I can actually do this sort of inductively. The first thing that I can do is I can take, well, you know what? The derivative of, I'm sorry, the derivative, double prime is the derivative of the derivative, right? So I could say this is S L f prime of t minus f prime of 0, right? Okay, now I can do the same thing. I actually know this thing because I have it right here, right? That's right. So S, let me put big parentheses around that. It's going to be S L of f of t minus f of 0 minus f prime of 0. Okay, so this thing here is this whole thing, right? So we're going to have, let me write this as s squared L of f of t minus s f of 0 minus f prime of 0. Let's do one more. Let's do f triple prime. Okay. L of f triple prime. Well, that's going to be s, times L of f double prime of t. I should put an s on here as well. Do that for completeness. Actually not there, but oh. There we go. Put one more up here. Sorry about this. It's just everyone who does math has a little bit of OCD in them. Just a tad. Some more than others. Okay, so as I was saying, L of f triple prime is S L of f double prime of S minus f double prime of 0. Okay, now we have a expression for f double prime, for L of f double prime. That's going to be S times, let me just copy and paste here. Okay, so that gives us, or that leaves us with s cubed L of f of t taken at s minus, now here it's s times, sorry. s squared times f of 0 minus s times f prime of 0. Okay. Shouldn't have had that there. Okay. Minus f double prime of 0. Okay. Oop, this one. Yes. Okay. Okay. Now, we're going to go ahead and pretend that we can do this as many times as we want, which we can. I'm not going to show the induction. But I think that you all can understand now how it's going to go. If I took the nth derivative and I want to take the nth derivative of the Laplace or the Laplace transform of the nth derivative, it's going to be s to the n L of f of t of s minus, now here we're going to have s to the n minus 1 f of 0 minus s to the n minus 2 f prime of 0 minus, and you keep going all the way down towards you get f the n minus 1 derivative at 0. Okay? Okay, and that's how we're going to use that. We're going to use that to transform differential equations. Okay? All right, I'll see you in, well, no, let's go on. Let's just go on and keep going. We can do this. Let's look first at, start looking at some problems. Okay, the first section in the book says use the table. There's a table on page 356. I'm not going to use the table. Want to know why? Because I have my Laplace transform thing queued up. Okay, so let's go ahead. We're going to use, you can use the table or you can use a Laplace transform solver that you've created, like I have. Okay, which is what we're going to do. So we're going to take L of 1 plus e to the negative t squared. Okay. And we should probably also say when it exists. Okay, so this is going to be, first thing I'm going to do, I'm going to expand what's inside the Laplace transform. So I'm going to expand that function to be 1 minus, or I'm sorry, plus 2e to the negative t plus e to the negative 2t, and then we're going to do that at s. Okay, now we can use linearity here. Okay, we did that last time. So that's Laplace transform of 1, okay, plus 2 Laplace transform of e to the negative t, okay, plus Laplace transform of e to the negative 2t. All of these are, of course, taken at s. I'm all in on my OCD right now, so I got to do that. Okay, so now let me go ahead, let's go to the Sage and the Sage math, and we're going to go ahead and calculate these Laplace transforms. Okay, so give me just a second. Stopping broadcast here. Starting broadcast here. Okay, you guys see that I have my Laplace transform saver from the other day. Okay, so The first Laplace transform I wanted to take was just the Laplace transform of 1. We did that the other day even, but let's just check. Our assumption on S should be that it's bigger than 0. Okay. And if everything works, we should get, calculating, 1 over S. Okay. That works. Write that down for Laplace transform of 1. The next one we're going to do is the Laplace transform of e to the negative t. Now, I'm not going to change my assumption yet. Okay, I'm going to think about it real quick. I know what it should be. I need what? According to the first theorem we said, our S should be bigger than -1. I'm not going to put that assumption in, and you're going to see it's going to spit out something wrong. Nope. Maybe I have the algebra wrong. Let's check. That might, yep, there's where it's wrong. So our assumption should be actually S is bigger than 1. Well, let's just keep S is bigger than 0. Okay, we're gonna talk about that assumption in a minute. Okay, we'll see what's going on there. Finally, e to the negative 2t. Okay, let's take e to the negative 2t. Let's keep the same assumption, see what happens. Seems to work. We'll have to look at those assumptions in a second. Okay. Actually, I think I can do, let's say, nope. I got to look at those assumptions. Okay, 1 over S plus 2. Let's go back to the, yes, let's go back to my good notes. Okay. No problem here. S bigger than 0, that's fine. That's 1 over S. And we need, our assumption is S is bigger than 0. Okay. Oh, sorry, I haven't shared my screen yet. Okay, so like I was saying, the Laplace transform of 1 is 1 over S for S bigger than 0. Here, the Laplace transform of e to the negative t is 1 over S plus 1. Okay, so we need, actually, another way to look at it is we need S plus 1 bigger than 0, or S bigger than -1. Should have worked if I put -1 in there. Let me just check that one more time. Yeah, -1 should have been the right assumption there. I don't know why my thing was spitting up on that. Here, e to the negative 2t, okay, that should have been 1 over S plus 2. And again, S should be bigger than -2. Again, it shouldn't have spit it out, okay? For our, that is the proper assumption in order for that to exist. Just look, for example, integral e to the negative st, e to the negative 2t dt. If we want to look at that, for example, e to the negative s plus 2t dt. So in order for that to exist, we need, of course, this is from 0 to infinity. In order for this integral to decay, then we need s plus 2 should be bigger than 0, s bigger than -2. Okay, so that's how you do these things. You could also, of course, use the tables as well. Okay, all right, I'll see you all in the next video.